Okay, IED, we're going to be doing activity 2.1.5. This is going to be develop the solution of the redesigning a protective case. And this is the one that requires the most amount of work. So we're going to have to make sure that we pay careful attention to everything that we need inside the develop the solution. So check over the checklist and make sure that you provide all the deliverables that you can get for this entire section. And here we go. It says that we're going to, everybody individually is going to develop separately a 3D model for a potential solution to the problem. Later, you'll compare designs and discuss potential improvements to each design. So, carefully consider the hinge design for your protective container. Document your hinge design with a concept sketch and provide annotations that detail the tolerances you intend to specify to allow for proper interaction between the components. So this is using some stuff we found back in 2.1.1, which was the tolerances and what you would expect to require for a tolerance to fit in and not be too big, but also not be too small, but you want to have that friction to be able to move it back and forth. So keep that in mind. You're going to need those tolerance values. Individually develop a CAD model for each component of your design option. Important, emboss the name of your product or identifying text on your components to distinguish them from classmates' printed projects. So you're going to need to put your name or your company name or initials or something on there with text. So remember to do that. You use the text option on the sketch and then you can extrude that text. I may make a reminder video for you guys on how to do that one. Let's see here. Create a Cad assembly of your new protective case design. So apply appropriate joints to simulate realistic motion. So what you're going to be doing is you're going to be applying the mates in order to make this work. So you're going to have three parts. You're going to have the bottom part of the box, you're going to have the pin, and you're going to have the top part of the box. So you've got the bottom part of the box, the pin, and the top part of the box. And you're going to try to put all of those, all three of those together on the assembly so that you can actually open and close it in your assembly design. So let's see here. Next part, meet with your partner to review each of your designs, demonstrate the motion, discuss the similarities and differences. If you're digital, you can do this part yourself. You can double check yourself to make sure that the motion actually works out. You can see the similarities and differences between some designs. I can try to put up some examples in Canvas for you guys to see that you can find differences and similarities between. Let's see here. Revise your part and assemble the model as appropriate, and then document your new protective case design with a set of working drawings. So you're going to need to make a drawing of your assembly that's going to include like having an exploded view and also a bill of materials as well. So what we did with the documenting our assembly, you need to document, you need to make a document, a drawing of that assembly, and you need to include that as well. So there's a lot of different stuff in the develop the solution. Make absolutely sure that whenever you go through this one's going to take a little time. Make absolutely sure that you have all of them and that you're not rushing through it, because if you're rushing through it, you're not going to get graded very high. Make sure you have the burden of responsibility. It's on you to make sure that you turn in the evidence to me that is required. I'm telling you what is needed right here. You are providing what is needed. If you turn into me halfway stuff, you'll get halfway graded. That's just how it's going to be. Y'all have a great day, and I'll talk at you later.